strength. It is equal to 5.6 times normality. And as we know that 5.6 times formula of normality is percentage strength into 10 upon 70. That means normality can be written as percentage, mass percentage per unit volume, mass by volume percentage into 10 by equivalent mass. Now this single formula we have written, and by this formula we can calculate percentage normality or volume strength. It can be 11.2 times molarity. And molarity is 11.2 times percentage into 10 upon 34. So volume strength can be related to normality and molarity by this direct formula. We can solve numericals of hydrogen peroxide by using this basic formula of H2O2. For example, if we have a numerical that find the percentage strength of 10 volume hydrogen peroxide. Numerical is find percentage strength of 10 volume hydrogen peroxide. This is the question. Now 10 volume means volume strength is given to you as 10. And we want to calculate percentage, so we can easily calculate percentage. It is going to be, the solution will be 10 is equal to 5.6 into percentage into 10 upon 70. Now this percentage is our question. It means it will be 10 and 10 cancelled. Percentage strength of this numerical is going to be 17 upon 5.6. That will be the answer. Question is clear? In this question, we want to calculate percentage strength from volume strength. Another numerical we can have is calculate the molarity of 10 volume H2O2. Calculate the molarity of 10 volume H2O2. You can solve this question. Easy question it is. Formula is written. You can just solve the numerical. One more question is there. Find the volume of oxygen at STP liberated if 25 milliliter of 30 volume H2O2 is taken. Let's solve these questions. Now this question number 2. Ten volume is equal to 11.2 into molarity. The molarity will be 10 upon 11.2. That is the direct answer. Now in this third question, volume of oxygen produced. Now you must know that 30 volume means what? 30 volume means 1 milliliter is going to give us 30 milliliter oxygen. 1 milliliter hydrogen peroxide is going to give us 30 milliliter of oxygen, 30 volume oxygen. Now we are having 25 ml of this solution. So answer will be 30 into 25. That will be the answer at STP. So this is a type of numericals which can be there in your hydrogen peroxide topic, 20 volume, 30 volume, 5 volume and so on. We can solve numericals of hydrogen peroxide. Now we move on to the properties of hydrogen peroxide. Next topic we are going to start is properties. Properties of hydrogen peroxide. Just note it down and we'll start with the properties of H2O2. Properties of hydrogen peroxide. We have physical properties first. H2O2 it is liquid at room temperature. Bitter taste is there. Highly reactive. Stored in dark bottles. Lined by paraffin wax. Boiling point of hydrogen peroxide is greater than boiling point of water. Boiling point is calculated, not experimentally observed. Hydrogen bonding is present in this hydrogen peroxide. That is the reason why its boiling point is more than that of water. Because in hydrogen peroxide there are two OH groups and those are leading to more number of hydrogen bonds as compared to water. Now why boiling point cannot be determined experimentally, it is to be calculated. Reason for that is if we have 1 atmospheric pressure and vapor pressure curve, a liquid will boil when its vapor pressure becomes equal to 1 atmospheric pressure. In case of hydrogen peroxide, before we get this final value of boiling point, it will decompose. This is the boiling point of H2O2 and hydrogen peroxide will decompose before its boiling point. Decompose before its boiling point. Therefore, you have to go for boiling this liquid under reduced pressure condition. What we can do is, we can boil this hydrogen peroxide under reduced pressure. What does it mean? We can boil hydrogen peroxide under reduced pressure means we can reduce pressure like this. This is 1 atmosphere and now we have reduced pressure that is very less than 1 atmosphere and hydrogen peroxide is heated. So this is going to boil at this temperature. This is the boiling point at reduced pressure condition. On lower side we have temperature, here we have temperature and on this side it is pressure. As we can't reach at this value, we boil this liquid quite earlier. Now we can use the formula of log P2 by P1 is equal to delta H vaporization by 2.303 R 1 by T1 minus 1 by T2. From this formula, now if the pressure is P1, the boiling point is T1. If pressure is P2, boiling point is T2. We have calculated pressure. Reduced pressure is, let us suppose, P2, and boiling point is, let us suppose, T2, and initially pressure is P1, boiling point actual will be T1. Like that. So we can calculate the value of boiling point, temperature of boiling we can calculate, and that help us to know the values. So we can say pressures and temperatures are variable here. We can change the values. We can reduce the pressure up to this limit or up to this limit or up to this limit. Accordingly, we can calculate boiling point of liquid. In this formula, when we put the values, you must remember that T2 must be greater than T1. It means T2 must be greater than T1. This is T2. This should be T1 now. This is P1 and this should be P2. Only then answer will be positive, otherwise answer will be negative. This is how we can calculate boiling point of hydrogen peroxide like liquids. Those are decomposable. This is about your hydrogen peroxide. Now it is soluble in water. This can be very well understood. Now its dipole moment is greater than that of water. And reason for the dipole moment is again presence of two polar bonds, and resultant is going to be 2.1. Next point we must know about hydrogen peroxide is decomposition of H2O2 and its storage. Boiling point is 151 degrees Celsius for hydrogen peroxide. Now decomposition and storage. Next topic is decomposition and storage of hydrogen peroxide. What is the boiling point of water? Boiling point of water is 100 degrees Celsius, but that of hydrogen peroxide is 151, which cannot be measured experimentally, which is just calculated fact by using a formula. This we have explained. Hydrogen peroxide is not very stable. It's going to decompose to give us water plus oxygen. Factors, those are going to enhance this decomposition. Factors enhancing decomposition are sunlight, concentrated sulfuric acid or sulfuric acid ions, heavy metal ions, rough surface, all these factors are going to increase the rate of decomposition. It means rough surface decompose, light can decompose hydrogen peroxide, acids can decompose hydrogen peroxide. Therefore, hydrogen peroxide is to be stored in. Now we have to store it in amber colored bottles. Those cannot allow light to enter into the hydrogen peroxide bottle, and small amount of chemicals are added. Those are negative catalysts. So now we are storing it in the hydrogen peroxide H2O2 stored in amber color bottles to avoid light colored bottles, we can say brown, dark brown bottles. Smooth surface is provided. Smooth surface is provided by polythene or polymeric coating inside bottle. Phosphoric acid is added. Acetinolide is added. Glycerol is added. Sodium stannate is added. All these are negative catalysts. These are negative catalysts. Those are added to the bottle in order to retard the rate of decomposition. It means rate of decomposition can be retarded by adding chemicals like phosphoric acid, acetinolide, then glycerol, then we have sodium stannate. These chemicals are negative catalysts for decomposition of hydrogen peroxide. This is all about your storage and physical properties we are finished with. Now we move on to the chemical properties of hydrogen peroxide. First chemical property we must start with is acidic character of H2O2. First chemical property is acidic character. We'll start with acidic nature of hydrogen peroxide. Should we start? Acidic character of hydrogen peroxide. Acidic character of hydrogen peroxide. Hydrogen peroxide dissociate to give us H positive plus HO2 1 negative, and then this HO2 1 negative is going to decompose to give us H positive plus O2 2 negative. That means this is going to be a dibasic acid. As it can give 2H positive ion, it's dibasic acid, and equivalent weight as we have done earlier, it's going to be 34 by 2, which is equal to 70. Some of the reactions like barium hydroxide, it is a base. When it reacts with hydrogen peroxide, we get formation of barium peroxide plus water. And this reaction is indicating that this base is reacting with acid. The acidic nature of hydrogen peroxide is visible. Same way, if we have sodium carbonate plus hydrogen peroxide, we get sodium peroxide plus water plus carbon dioxide. Another reaction we can have is if we have sodium metal reacting with H2O2, we get sodium HO2 plus half hydrogen. And this reaction here indicating that metal react with acid to give us hydrogen gas. And this reaction is further carried out, we can get Na plus H2O2. We may get Na2O2 plus hydrogen. And all these examples are indicating that hydrogen peroxide is going to be acidic because it can react with metal carbonates, metal hydroxides. From these reactions, it is clear that H2O2 is stronger acid than water because it can produce water. And it is stronger acid than carbon dioxide also because it can produce carbon dioxide. So we can say stronger acid than water and stronger acid than carbon dioxide. That is the nature of hydrogen peroxide. It is acidic. It is more acidic than water, more acidic than carbon dioxide. It means acidic character, if you want to understand, so we can say H2O2 is stronger acid than CO2 and then water. That's about your acidic nature of hydrogen peroxide. Now here we have an important point. I missed that point. And that point is, if hydrogen peroxide is decomposing, what do you think? This reaction must be exothermic or endothermic? Generally, we know that decomposition is always endothermic. But here decomposition is going to be exothermic because products formed are stable than that of reactants. Reactant is less stable, product is stable. You must remember that decomposition reactions are not always endothermic. The term always is wrong here. All decompositions are not endothermic. Hydrogen peroxide, decomposition of hydrogen peroxide, ozone, these are going to be exothermic decompositions. That's all about your acidic character of H2O2. We are finished with the topic acidic character of hydrogen peroxide. That's all for today's topic. We'll continue with the oxidizing and reducing properties of hydrogen peroxide in the next coming class. Thank you.